Welcome to this problem section on solving right triangles. And let's get started right away. We have a small number of problems here. This triangle here, ABC, and then the sides ABC, it's not to scale because it's supposed to work for all these different problems here. If angle A equals 34 degrees, and A is given as 22 meters, find the hypotenuse C. Notice that A is the opposite of the angle, so, and then C, of course, the hypotenuse, so we're going to use sine. Of course, sine of A equals A over C, which then, of course, means that C equals A divided by sine of angle A, respectively. Of course, 22 meters divided by sine of 34 degrees. I think I'm going to push this onto the next line here, sine of 34 degrees. And I'll be solving this here soon on the graphing calculator. But for now, I'll leave it like this here and I'll do all of them together. I'm just going to write it down here on the side so I won't forget what I'm supposed to do here. Okay, the next one here, A is 34 degrees, B, the adjacent is 55, and we're supposed to find the hypotenuse, so of course we're going to use the cosine. A equals B over C, and then of course C equals B divided by cosine A, and then of course that is, let's see, 55 meters divided by cosine of 34 degrees. And let's see, yep, there we go. Again, I'll write this down here on the side so I won't forget what to do. Then the next one is going to be B equals 24.5 degrees and the hypotenuse C is 2.34 degrees. Find the adjacent A. Notice that this time A is the adjacent because we're talking about the angle B. So with the adjacent we have the cosine again. Cosine B equals A divided by C. This time we're supposed to find A, so A is going to be C times cosine B. And let's see if I can borrow a times sign from somewhere. There it is. So those are I'm going to put times. So and then of course is going to come out to equals 2.34 feet times cosine of 24.5 degrees, and we'll see what we come up with for that. And again, I'll write this down on the side, 2.34 times cosine 24.5 degrees. And I think I changed my mind. I'm just going to do this on the calculator later. No, I'll do it on the graphic calculator on screen. I just was about to change my mind and do it on the side and write down the result, but I'll show you on the graphic calculator how to do it. So next one would be B equals 16.9 degrees. C is given the hypotenuse, and find B. This should not be a capital B, this should be a lowercase b, which is the opposite, so we have to use the sine of B equals B over C. And then, of course, we have B equals, copy and paste this here, B equals C times sine B, and then of course numbers are 7.55 centimeters times sine of 16.9 degrees. And let's see what we come up with for this one. I think I just got myself a little bit more space. And the last one is going to be B equals 55.33 degrees. The opposite B is given 12.34 yards. Find A, the adjacent, so that should be the tangent. Tangent of B equals B over A. Again, if we look at that triangle here, tangent B is the opposite B over A. We're supposed to find A, so A is going to be B times tangent B, which is going to be the same as 12.34 yards times tangent of 55.3 degrees. There. And give me a moment to write this down. 12.34 times tangent. And the last one was 7.55 times sine 16.9. And I think I got them all. So I can go over to the graphing calculator. Okay, the first one was 22 divided by sine of 34 degrees. And we come up with 39.3. And then I have to see how we should round. It doesn't say so. Personally, I would round to the same significant figures that we had, and that is 22 and 34, so two significant figures, 39 meters. The next one is going to be 55 meters divided by cosine of 34 degrees. So 66 meters. Then we have 2.34 times cosine of 24.5 degrees. So let's see, 2.13 feet. So that's this time. And in the meantime, I guess I can already check my answers, and so far that's what the book has. Then 7.55 times sine of 16.9 degrees, 2.19 centimeters, and 12.34 yards times tangent of 55.33 degrees, and I come up with 17.8 yards. 17.84 yards. However, I'm looking in the book and perhaps I made a mistake. Let me double check that. What went wrong? I'm going to go back to Word for once. The first four results were correct, so I'm going to plug them in. So this one here was 39 meters. Notice that with A being 22 meters, the hypotenuse C has to be longer, and that is achieved by dividing by the sine. The sine is always between 0 and 1, or 0 and -1. So C always has to be at least larger than A, so this makes sense. Same thing on the next one with B equals 55. The hypotenuse comes out to 66 meters. Again, it has to be larger than either one of the other legs. The next one is going to be 2.13 feet, and the fourth one is going to be, let's see what I come up with, 2.19 centimeters. And then I'm going to double check what I did wrong on the last one, where it says B is 55 degrees and B is 12.34 yards. Find A. So when I look at that here, it's going to be tangent B equals B over A, which is, oh, I wrote, no, which is B over A, which is what I wrote, and then A equals B divided by tangent B. There is my mistake. Yeah, that's my mistake. I'm not going to go back to the graphic calculator on the screen. I'm going to do it on the side here. 12.34 divided by tangent 55.33. And indeed 8.535, which is the same as what the book lists. Okay. Going to go on with the next exercise. Where it says refer to a right triangle ABC with equal to 90 degrees and find all the missing parts using the given information. So what's given is the angle A is 25 degrees and the hypotenuse C is 24 meters. Of course, C is also given as 90 degrees, and B needs to be the complement angle of A, because it's a right triangle, so 65 degrees. That was relatively quick. Then C equals 24 degrees. We're supposed to find A. There are several. I believe there's 4 or 6, I believe, different ways we can do this, or 4 to start out with. For example, if I have given the angle A of 25 degrees and the hypotenuse C, and I'm supposed to figure out what the opposite A is, well, I'm going to use the sine, of course. So in this case here, it's going to be sine A equals A over C, or A equals C times sine of A, which is going to be, so you go to one more line here, equals 24 meters times, and now I'm going to borrow myself a times symbol. So there we go. Times sine of 25 degrees. An alternative would have been to use the angle B and then use the cosine. But of course, any one of these is fine. So on the side, I'm going to do 24 meters times sine 25 degrees, and I come up with 10.14, which actually I want to round to 10 meters. Let's see. And so far I'm correct with what the book says for a solution. B, if I use the angle A here, that would be the adjacent, so this is going to be the same as C times, C times cosine A, which is going to be the same as 24 meters times cosine of 25 degrees, which is going to come out to 21.75 or 22 meters rounded. Okay, and the next exercise is going to be 26.5 degrees and 324 millimeters are given for angle B and side B. So C, of course, 90 degrees, and A is 63.5 degrees. And then A, since B is given, which is, let me use the angle A here because I'm just used to having it on the x-axis. So that would be, B would be the adjacent to it, and what's asked for is the opposite. So we're going to use the tangent. Tangent A is A over B. So A is B times tangent A, which of course is the same as, let's see, 324 millimeters times tangent of 63.5 degrees. Which comes out to 324 times tangent 63.5, 649.84, or rounded 650 millimeters, since it should be three significant figures. And C, well, I have lots of possibilities to figure out C. I could even use the Pythagorean b squared plus a squared equals C. Or I can use perhaps the cosine. So let's use the cosine. Cosine of A is B over C, and therefore C is B divided by cosine of angle A, which is the same as 324 millimeters divided by cosine of 63.5 degrees, which comes out to 324 divided by cosine 63.5, 726 rounded millimeters, which is what the book says as well. Okay, last exercise. Which says the following. In this problem, use the information given in the diagram to find the angle A to the nearest degree. So on the left-hand side, we're supposed to determine angle A. We actually don't know if this up here is a right angle, so let's not use it as a right angle. What we have given here is a 30-degree. So the way the problem is given is that this triangle, this black triangle here, is split up into two triangles. So we're going to deal with this triangle first. Looks like a 30-60 degree triangle. Respectively, we're going to determine this height h first. So the height h is going to come out to, well, it's the opposite to the angle 30 degrees, and the hypotenuse is given. So we're using the sine. H over 6 equals sine of 30 degrees, or 6 times sine of 30 degrees. And we can pretty much do it in our head. It's going to be 3, because sine of 30 degrees is 1/2. Times 6, of course, is 3. So we know that this height here is 3, which is the opposite from the angle A. And then we have given the hypotenuse. So again, we're going to use the sine on this one here. Sine A equals 3/4, or A equals the inverse sine of 3/4. Let's see what I come up with. So on the side here, I'm going to do sine, the inverse sine of 3/4, and I come up with 48.6 degrees, and perhaps we're supposed to round to 49 degrees. And as I said earlier on, the black triangle is not necessarily a right triangle. In fact, it's not. Notice that we have a 30-degree angle here. We have a 49-degree angle over there, which makes this actually here a 101-degree angle. I believe I did draw them to scale. Okay, on the right-hand side, we have given 45 degrees here, and then we have a side of 2, and the height here, which we have to find first. So h equals, well, we could use the tangent, right? Tangent of the angle 45 degrees is height over the adjacent 2. But of course, we know in a 45 degree triangle that the other side here is 2 as well. And we also would know that from tangent of 45 degrees is 1, so 2 over 2 needs to be 1. That was relatively quick. So the height is 2. Angle A is supposed to be determined. We have now the height given and the adjacent. So again, we use the tangent. Tangent A equals 2/3, or A equals tangent, the inverse tangent of 2/3. And we figure out what we come up with. Inverse tangent of 2/3, 33.7, or around 34 degrees. And with that, I conclude this session on problems for this section.